Alright, let's try this one more time. This is the review for the second MMA test. First thing we're going to look at is finding number of outcomes. This is the counting principle. What we're going to do, we read the question, how many different outcomes are there for rolling a die? Well, there are 6 outcomes on a 6-sided die. 1 through 6. Flipping a coin, there are 2 outcomes, heads or tails. And then picking one card from a deck of cards. Well, there are 52 cards in a deck of cards. With the counting principle, we simply multiply those. 6 times 2 times 52. How many different outcomes can we get? Let's grab our calculator. 6 times 2 times 52. And that gets us 624. 624. Based on that answer, what is the probability that you will get a 5 on the die, a tails on the coin, and the king of hearts? Okay, so a 5 on the die, this is a 1 out of 6 probability. Tails on the coin, that's a 1 out of 2 probability. And the king of hearts, there's only one of those, 1 out of 52. Those are probability of each of these. If we have multiple different probabilities, have to do this, then this, we multiply those. So we are going to multiply these, and that is going to be my probability. Again, I can grab my trusty calculator out. When you're doing fractions, and especially probability, always use alpha. Y equals to get this fraction. First one is 1/6. Then I multiply that by alpha y equals 1 over 2, and then I multiply that by alpha y equals 1 over 52, and I get 1 out of 624. If you notice, those numbers are quite similar. There are 624 options. This is simply one of them. Carly has 3 pairs of shoes. Let's change colors to make it a little bit more visible. Carly has 3 pairs of shoes, 14 shirts, 6 pairs of pants to choose from to wear to school. How many different outfits can she make? Well, 3 shoes times 14 shirts times 6 pairs of pants would equal, and I could gladly grab my calculator. 3 times 14 times 6, 252. She could wear 252 different outfits with that combination. Alright, we're moving on to permutations and combinations. Remember, permutation, we have order and then combination, we don't care about the order. When I do a permutation in the calculator, I do NPR. When I do a combination in the calculator, I do NCR. From a class of 30, a group of 4 is being chosen. Is this a permutation or a combination? 30 group, do I care the order of the 4? No. So this is a combination. I do not care what order they are chosen in. 4. Officers are being chosen in a club with 25 members. It doesn't say there's different officers. It does not say president, vice president, anything like that. It's just officers. There is no order to that, so that's a combination. A child is arranging Barbie dolls on a shelf. That's a permutation because we have Barbie dolls. The first one's here, second one's here, something like that. We have an order to them, so that would be a permutation. My 4 dogs all want to go with me in the car. I choose one to sit in the front, one in the back. So the order definitely matters with this. One to sit in the front, one to sit in the back. That makes a difference. That's a permutation. And then 55 people running in a race. Ribbons are given for 1, 2, 3. Specific place, first, second, third, fourth place. That's a permutation. Look at that, CC, PPP. Wonderful. Alright, next one. We're going to decide if it's a permutation or a combination, and then we're going to solve for the answer. How many groups of 8 toys can a child choose to take in the car from a toy box with 30 toys? Okay. 8 toys. Do I care what order I grab the toys? I don't care. There's no order, so this is going to be a combination. So let's set it up. So combination, we use N, C, R. I start with how many I have to choose from. I have 30 to choose from, and of that I only need to grab, or I only can grab 8. So that's what I put in the calculator. We start with the 30. That's my 30 I have to choose from. And then we go to math, and all the way at the right side there's the probability. And there's our NCR and NPR. We have NCR there. Tap NCR. And I have 8 I need to grab. Whoa. That is a lot. That is 5,852,925. Let's see that. Let's just change that to a permutation and see what it looks like. A lot more there. This is a scientific notation. I don't think any on the test will have this. You have to move that decimal place 11 times. So a permutation, since the specific order, will always be more. Permutations will always be bigger. Next one, there are 16 members of a club to be lined up for a yearbook picture. How many different ways can they be arranged? If they're being arranged, there's an order, just like the Barbie dolls above. That means it's a permutation. So permutation, we use in PR. We have 16 members, and those 16 members are we're using all 16 of those. We could also do something else in a second. So we have 16 total. Math, it is a permutation, and we're going to use all 16 of them. Other way we could have done that is 16 times 15 times 14 times 13 times 12 times 11 times 10, like we originally started off with, but that's a lot of work. So we're just going to go with this. To write that answer down, I don't think, again, that there's any of this scientific notation on the test. In case there is, you have to move this decimal. So let's go ahead and just write what we have. 9, 8, 9. Alright, and that's times 10 to the 13th. So we're going to move it 13 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we're going to move it 10, 11, 12, 13 more times. So 2, 0, 9, 2, 2, 7, 8, 9, 8, 9, 1, 2, 3, 4 zeros. So whatever that extremely large number is, that's how many different ways they could be arranged. Again, I don't think on the test that there are any scientific notation ones. You should just be able to write the answer, whatever's given here. Last one on here. From the 8 members of the school board, how many different ways can we elect a president, vice president, secretary, and treasurer? Those are specific. Those are specific people. So we have a permutation again. We're going to use in PR. There are 8 members, and we have a president, 1, Vice President 2, Secretary 3, and Treasurer 4. So we have 4 positions that require a different order. How many options can we do? Let's go ahead and plug that in. Go ahead and multiply that. We do 8, math, permutation, and it is 4 of them. So we have 1,680 different combinations for those positions. The Recycle Club has 30 members. How many ways can they choose a committee of 6 to coordinate pickup days? We don't require an order for that. If you're just on a committee, you don't have a specific job title, it's a combination. 30 members, NCR, and there's 6 of y'all to choose from. Let's go ahead and plug that in the calculator. 30 to choose from. Math, probability, NCR, 6, enter, we get 593,775. That's how many different combinations we could have for the committee. Kevin has 8 pictures to hang in his dorm room at college. How many different ways can he arrange them on the wall over his bed? I'm assuming there's an order. If you want your picture of your mom first, it's different from having a picture of your sister first. So we have a permutation here. There are 8 pictures in PR, and we're hanging all 8 of those. 8, and again we're going to do math, probability in PR, and we're hanging all 8. 40,320 different ways we can do that. Next one, we have 6 dogs who want to go with me in the car. If I can only take 4, I don't care who sits where. How many different groups can I choose? If I don't care where they sit, it's just a group. That's a combination. So I'm going to use NCR. There are 6 dogs, and you can only take 4. Let's see what we get. 6, math, probability in CR, 4, enter. There are 15 different possible groups of dogs you can take. Oh, didn't show all that. Last one of these. Miss Jones is taking 5 students on a field trip out of her class of 30. How many different groups can she take? There's no order, there's no specific which way to take the kids, so that is a combination. So we're going to use NCR. We have 30 to choose from, and we are only taking 5. 30. And then we are going to do math, probability in CR, only taking 5. Enter. 142,506. That's how many combinations I have. That is all the permutations, commutations, and counting principle questions that'll be on a test. Next video I'll do graph statistics, central tendency, all that stuff.